Let's look at our first use of sample size. We're going to talk about this twice. The first one is required condition for our particular calculation method. That was our second condition. The first one was unbiased sampling. What's our second condition? In order to use the formula to estimate P in this particular chapter, the sample size must meet the criteria n times P is greater than 10, n times 1 minus P is greater than 10, which interprets to the following. We need at least 10 successes, that's n times P, and 10 failures, which is n times 1 minus P. That's what we need. And again, why do you suppose we need the mentioned criteria above regarding sample size? So we can use the central limit theorem results. I guess concept is a better word. And what is that? That the distribution, in this case, of p hat, which is our statistic, is approximately normally distributed. So we need this to be true in order to use the application or the process that we're about to engage in. So we need to meet this criteria. Now, what is the smallest sample we can have in order to estimate P using the methods of this chapter? So let's look at this for a second. I need this to be greater than or equal to 10, and this to be greater than or equal to 10. All right. Well, n times p is the number of successes. So p is the true population parameter, and as the worst, the one that has the most variability occurs when p is equal to 0.5. As soon as we go towards 0 or 1, all of a sudden everything lumps into one side or the other, the success side or the failure side, which means achieving the 10 gets worse. So if p equals 10, well, if p equals 0.5, then the biggest sample you need, or the smallest sample possible to do this method, is 20. Because again, when we look at that, 20 times 0.5 gives you 10, which at least you have the equality going. And again, I could do it again, but you can see what's happening. 1 minus p is still 0.5. And again, I get the 10, which again, we have at least equality. Anything else, as soon as it becomes 0.4 or some other number, 0.4 times 20, for example, then that does not give you what you want. That only gives you 8, which fails to be greater than 10. And sure, on the other end, it meets the criteria, but we need to meet it. It's an and. This means it needs to be this and that, both meeting both, and we don't. So in this case, the rest, of course, have to be failures. So the rest have to be failures, which means there's 12. So 12 is they're bigger than 10, great, but 8 is not bigger than 10, so no. So the smallest possible sample size here is 20, and that's only if this thing happens to be 0.5. Now, consider the following scenarios. Determine which meet the required criteria for sample size to meet the CLT conditions. Now, remember we did this earlier, question 1 worksheet, here's the information, and if I remember correctly, that was 12, right? Yes, it was. So successes, 12 successes count. And this equivalent to n times, well, in reality, p hat. So here's the dilemma. Well, this is the formula. I can't use it because I just don't know what this is. That's the whole point of this. So in reality, that formula is going to get reduced down to n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. But in order to create p hat, we have to count anyway. All I need to do is count how many successes I have and failures, so I don't need to convert it first to a p hat to do this. I just need to count, right? So I have 12 successes, good. That means it's great. But the failures, well, there is 20 here. Again, n was a 20. So if that's all it was, then I have 8 failures. And that is a big no. I need 10 and 10, which means that this comes from n times 1 minus p hat. And the answer is no. I don't meet CLT. About question 2. Okay, let's see if I remember what this was. Oh yeah, I mean, I'm starting to look at it here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, 6. So in this case, I'm counting successes, failures. I'm going to call, yeah, the N was a failure. And as far as failures, I got 6 failures. That's my count. So I don't need to go any further. I'm not going to count the successes. I don't meet the criteria, not bigger than 10 or equal to it. So I don't meet CLT conditions. I don't have my failures is not over 10. My successes is because I can see this definitely has a lot more. I think it was 20. Or was this 28? I think, yes. So this was 28 originally. And that means, and then I would have 22 successes, which definitely is greater than 10. But because this one fails, this one succeeds, no good. Do people like the taste of product A over product B? A blind test of 120 participants showed that 80 liked product A and the rest chose product B. Is the sample large enough to meet the CLT conditions? Well, again, let's say success is I like product A. I have 80 successes, if that's the case. So that's product A. Clearly 80 is bigger than 10. What about the failures, people that did not like product A? Well, it's 120, so 120 minus 80, that is 40, which is also greater than 10. So I have enough successes and I have enough failures. So yes, I meet CLT conditions. As I have over 10 successes and 10 failures. Right, that's one question here. The last one. What proportion of households in Washington County have a landline? A random sample of 500 telephones result in 2% still having a landline phone. Is the sample large enough to meet CLT conditions? So if you notice in this scenario, I'm quoted p hat from the sample of 500. That's the result from the 500. So my sample size was 500, which seems pretty large. P hat then is 0.02. So now I will need to calculate 0.02, again using p hat instead of p because I don't know what p is. So what is 2% of 500? Well, that looks like, I think it's about, yeah, it's just 10, right? Just doing this in my head. Yeah, it's 10, which again, just squeaked by. And I'm not even going to calculate this part because, I mean, it's 500 here. I'll calculate it. If there were 10 successes, the rest must be all failures. So that's 490, which is clearly bigger than 10. So yes, I meet CLT conditions. And all that means is that this is the shape that I can draw concerning the sampling distribution of proportions.